Today we are going to continue with calculations on stoichiometry. And we are going to look at the relationship between mole, concentration, and volume. The relationship between mole, concentration, and volume. So we have that concentration, C, is equivalent to N over V. So, making N the subject of the formula, we have N is equivalent to CV. N equal to CV, where C is concentration of solution in mole per dm cube, and V is volume of solution in dm cube. Volume of solution in dm cube. So this formula can be changed to N equal to CV over 1000. You can change this formula to N equal to CV over 1000 if volume is in cm cube. So when the volume of the solution is in cm cube, use the formula N CV over 1000. But if the volume is in dm cube, use the formula N equal to CV. Alright, let's take a problem. Let's take a problem. Number 1.325 grams of anhydrous sodium triisocarbonate 4 was dissolved in water. Was dissolved in water to make 25 cm cube, 250 cm cube of solution. Calculate the molar concentration of the solution. Calculate the molar concentration of the solution. Now we have the mass of the anhydrous sodium triisocarbonate 4 that was dissolved in water, and what volume? 250 cm cube of solution. To make up 250 cm cube of solution, we are asked to calculate the concentration of the solution. So the first thing we do is to use a format of N equal to mass over molar mass. Now, what molar mass are we looking for? We are talking about the molar mass of sodium triisocarbonate 4. So first of all, we calculate the molar mass of sodium triisocarbonate 4. Calculate it. We now have molar mass of sodium, molar mass of Na2CO3 is Na times 2 plus C times 1 plus O times 3, oxygen. So we now have 23 times 2 plus 12 times 1 plus 16 times 3. And that will give up 106 gram per mole. That's the molar mass of sodium triisocarbonate 4. So from there, we find the amount or what we call the number of moles of this sodium triisocarbonate 4 that is found in this 1.325 gram of the salt. So we now have number of moles N, or amount N, is giving us 1.325 divided by 106. And that will give me, or that will give us 0.0125 moles. 0.0125 moles. That's the number of moles of sodium triisocarbonate 4 containing 1.325 grams of this salt. Now we are going to determine the concentration. We said the concentration or molar concentration C is giving us N times 1000 divided by volume. Recall that we have that we have N equal to CV over 1000. So how did we get this? We have to make C the subject of the formula. And so we cross multiply, we have N times 1000 divided by V. So let's apply this. Let's get rid of this and apply this. We are looking for the concentration. And what is our N? Number of moles is what? 0.0125 times 1000, all divided by the volume. What is the volume? 250. And that will give us 0.05 mole per dm cube. 0.05 mole per dm cube. We are going to take another question. The second, I will start. All right. The question says, how much zinc will be left unreacted if 3.0 gram of zinc is reacted with 20 cm cube of 0.10 mole per dm cube of tetraoxosulfate 6 acid, given that the relative atomic masses of zinc, sulfur, oxygen, and hydrogen are 65 for zinc, 32 for sulfur, 16 for oxygen, and 1 for hydrogen. Now, here we have been given the equation for the reaction. Now, how do we start? We start by determining the number of moles of tetraoxosulfate 6 acid in 20 cm cube of 0.10 mole per dm cube. That's the first thing we do. So we now say solution. Solution, where we have N is CV over 1000. And we are talking about the N, number of moles of tetraoxosulfate 6 acid. And that is equal to, what is the concentration? 0.1. 0.10 is the concentration of the tetraoxosulfate 6 acid. The volume is 20, all divided by 1000. And that will give us 0.002 moles. 0.002 mole. So in 20 cm cube of 0.10 mole per dm cube of this acid, we have 0.02 mole of the acid. Now from the equation, we have that 1 mole of zinc will react, or rather reacted, with 1 mole of the acid H2SO4. The equation is telling us that 1 mole of zinc reacts with 1 mole of the acid. And then we have that the acid contains 0.002 mole. That is, we have 0.002 mole of tetraoxosulfate 6 acid in 20 cm cube of 0.1 mole per dm cube. And that is the quantity we are told will react. So let's find out the quantity of zinc that actually reacted. So we now have that if in the equation tells us that 1 mole of zinc react with 1 mole of tetraoxosulfate 6 acid. Therefore, 0.002 moles of zinc will also react with 0.002 mole of what? Tetraoxosulfate 6 acid. 0.002 mole of zinc will react with 0.002 mole of tetraoxosulfate 6 acid. So we want to find out the mass of the zinc that constitutes this 0.002 mole of zinc. So we now have that N is equal to mass of the zinc divided by relative atomic mass of zinc. Mass of the zinc we are talking about divided by relative atomic mass of zinc. So the mass itself will be giving us the amount, which is 0.002 multiplied by the relative atomic mass of zinc, which they gave us to be what? 65. And that gives us 0.0130 grams of zinc. So 0.130 gram of zinc was what actually reacted with this 20 cm cube of 0.01 mole per dm cube of the acid. That's the mass of zinc that reacted with this. So the question is, how much of this zinc will be left unreacted? We are to determine the mass of the zinc that did not react. So the mass of zinc, unreacted zinc, mass of unreacted zinc is equal to 3.0 of zinc that was given minus 0.130, all in grams. And that will give us 2.87 grams. 2.87 grams of zinc did not react. Thank you very much. I hope you understood what I just taught now. Please drop your comments or questions at the comment section. Thank you.